All right, moving on to number 10. A, we're trying to find an interior angle inside of the circle. And then B, we're trying to find an angle that is outside of the circle. Okay, so the interior one was where we add the two arcs together and divide by 2. So we would have 50 plus 80 divided by 2. That is equal to angle 1. And then the other problem, we have 70 minus 20 divided by 2, and that is equal to angle 1. So let's see here. 50 plus 80, 65. So this angle is 65. And this one is going to be 50 divided by 2, so that one is going to be 25. Okay, so interior angle, exterior angle. All right, so let's take a look at number 11. First, we need to find the area of a trapezoid, and then we need to find the area of a triangle, and then we need to combine them in that other figure. Now, I did miss a number on that figure for the practice test. You can see right here, that is 3 right there, but there's nothing written right there. That should also be a 3. That makes it an isosceles trapezoid. Not that it has to be that in order to figure out the dimensions, but I did want that to be an isosceles. On the test, I did not miss that number. Okay, so area of a trapezoid is equal to B1 plus B2, base 1 plus base 2, divided by 2 times the height. So the area of the trapezoid for A, we're looking at 10 plus 15 divided by 2, multiply that by 8. Okay, so 10 plus 15, 25. 25 divided by 2 is 12.5. 12.5 times 8 is 100. So the area of that trapezoid is 100. Now the area of a triangle is equal to base times height, all of that divided by 2. So let's see, what do we have here? 11 times 4, almost couldn't read that, divided by 2. So 44 divided by 2 is 22. So there's the area of B. Now, for both of them. Okay, so the area of the trapezoidal part on C, let's see, base 1 is going to be 20, or I would say the shorter base will be 20. You could call that base 2 technically if you want to. It doesn't really matter. So 20 plus the base on the bottom is 26. Divide that by 2. And it looks like the height is 8. So that is the area of the trapezoid part. And then we're going to add to that the area of the triangle part. So the base is 20. The height is 7. And then divide that by 2. So let's figure this part out first. So 46 divided by 2 is 23. 23 times 8 is 184 plus 2 times 7, so we've got 140 divided by 2 is 70. So 70 plus 184, 254. So the area of the entire figure is 254. Now, if you really wanted to, you could split that trapezoid up into a rectangle and then 2 triangles on each side of it, one on each side. If you really, felt like you needed a little bit more pain in your life, you could do it that way. But the easiest thing is a trapezoid and a rectangle. Now, moving on to number 12, we want to find the area of the sector. So the area of the sector is equal to the degrees divided by 360 times the area of the triangle. So that would be pi r squared. So we take the area of the circle, but we only want a fraction of it. And the fraction is denoted by the degrees divided by 360. So what our degrees is 95 over 360 times 3.14 times the radius squared is 49. So let's see here. 95 over 360 times that by 3.14 times 49. 40.6. So that is the area of that sector in that circle, created by a 95-degree central angle and a 7-unit radius. Now, for number 13, this is one that people consistently get wrong. I don't know exactly why. I just know that it happens because I've been teaching this class for a few years now, and this one gives people trouble. All right. Now, I didn't give a major axis and a minor axis. All I gave was 6 and 8. And that is, let me try to, I'm really terrible at drawing ellipses. I just use my template. Okay, so I have a 6 right here and an 8 right there. Okay, this 6, I mean to show you that the 6 is from the center to this edge right there. And the 8 is from the center to this edge right here. This is not the major axis, this is not the minor. The minor axis in this case would be 12. The major axis would be 16. Okay, and then the area of this would be equal to A times B times pi. Remember how close this is to a circle. Remember, a circle, the major and the minor axis are the same, and half of each of those is the radius, so that would be the radius squared, or the radius times the radius. So what we have here is from the center to the edge, which is going to be 6, and then from the center to the edge, which is going to be 8, and then we multiply that by pi. So that is 150.7. 150.7. So remember, it's just 6 times 8 times pi.